afternoon's webinar. It's all about Haemonchus and the challenge of treatment and decisions that you're faced on farm as advisors, as SQPs. And the point of today's webinar is to go through some of the practicalities of Haemonchus the worm, and then what we can do about it, and how to resolve and handle some of those cold-face scenarios that vets, SQPs and farmers face. Just to be clear, this is focusing specifically on sheep this afternoon. There may be people with other interests, but our main focus this afternoon is Haemonchus in terms of affecting sheep. My name's Chris Lloyd. I'm Secretary General for Rumour Agriculture, and we're really pleased to be bringing this webinar with you this afternoon with the brilliant support from SCOPS, Morden, the Sheep Vet Society and Edinburgh University. But the whole SCOPS family have been involved in promoting this, so it's great to see such a wide attendance this afternoon. As I've mentioned, everyone's cameras, bar the presenters, are off, and you should be muted so that we don't have any disruptions. If the webinar will be recorded, and we'll post that on the Rumour webinar in a few days. So we've been receiving a few emails this afternoon because people have got work commitments and haven't been able to make it. So we will have the recording online in a few days. We will take questions at the end of the session. We will have a panel session with all of the speakers. And if you've got a question, please post it in the chat. This afternoon's event will be open for CPD points, and I'll leave Neris to cover the details of that later on. I think you can get basic points by just attending the webinar, but AMTRA will have a more detailed questionnaire in their AMTRA library for AMTRA registered SQPs to get more points. So I think the beeps have been quieting down. Most people are joining the webinar. So I'll introduce our speakers. I'm pleased to welcome Dave Bartley from the Morden, Rob Kelly from Edinburgh University, Neris Wright, who's representing SCOPS this afternoon, but is an independent sheep advisor, and Jonathan Hobbs, who's a practicing vet down in the Southwest. Welcome, everybody, and thanks very much for giving your time this afternoon for this webinar. So I think we'll kick off. Our first presenter this afternoon is Dave Bartley, who's going to give us a bit of a background to the worm and why it's such a pain to deal with in terms of a sheep farm. Dave, over to you.
Right, thanks, Chris. Right, this is where we hope the tech does as it's meant to, and we get share. Right. Okay, is that sharing? It did before, but I can't see it yet. Right, okay.
Yeah, that's working fine, Dave.
Okay, cheers. Right, okay. Well, thank you very much for the invitation to talk about this. For those of you who've met me before, I am passionate about all things relating to worms and parasites. So yeah, I was challenged with talking about Haemonchus, the parasite, and thinking about some of the facts. Right. Okay. When I was putting it together, I thought actually there's a lot of statements out there across the place about Haemonchus. There's a lot of misconceptions, a lot of sort of myths going around. So I thought I'd actually set up my talk around those sort of questions and challenge some of those. So really, I ended up with 6 sort of statements that I have heard and others have heard. And I thought I'd go into each of these. You know, the first one being Haemonchus is different from other roundworm species. Haemonchus is much more pathogenic than other roundworms. Haemonchus is only an issue in the south of England, so it's not an issue in the rest of the UK. Sheep do not develop immunity to Haemonchus. Haemonchus can only survive a UK winter in animals, and multi-class resistance in Haemonchus doesn't exist in the UK. So, as I say, I'm going to center my talk around that sort of framework. I thought I would sort of put this into context. So the first one is the Haemonchus is different from other worms. Well, I thought actually it was probably worth a few moments just to talk about the other worms. I like showing this as much because over the years I've been doing it, we've got a whole bunch of lovely imagery which really highlights the sort of depth of roundworms and the shapes and sizes, and actually that is very much represented in what they do, when they do it, and how they do it. So we have something like 11 different types of worms in the UK that infect sheep. They cause different problems throughout the year. Interestingly, their susceptibility to anthelmintics and their ability to develop resistance differs from each of those roundworm types. And it's therefore sort of the treatment options that you might have for them may actually differ. And you'll learn a bit more about that from speakers afterwards. So the major worms that we have are listed here. And it really is just, I wanted to highlight this because I don't really talk about resistance much going on. But if we're thinking about resistance development, Haemonchus and Telodossagia are the two parasite species that actually develop resistance more readily across the piece. So not just in the UK, but across the world. The species, the scoureworms and the thread-necked worms, Nematodirus and Crixorongulus. Chris says that we have a whole wide range of people from different countries. Some of those you'll have, some of them you won't. And yeah, their likelihood of developing resistance is not as high. And things like Caperia in sheep, we don't tend to see huge amounts of resistance. So if we're thinking about actually Haemonchus, what is the parasite? It's also known the barber pole worm or the wire worm, depending on where you are. It's a voracious blood feeder. 10 of them will drink about 0.5 ml of blood a day. And it's fine. It's a very adaptable parasite. It's found in diverse climatic regions, all the way from the Arctic down to the tropics. It is predominantly a sheep and goat parasite in the UK, but it will go in cattle. And as Chris said, we're not really going to talk about that, but it's just to highlight that it can be found in there. So, that is important. It has a high biotic potential. What do I mean by that? It has the ability to generate an inordinate amount of eggs. The sort of estimates are somewhere between 4 and 10,000 eggs per female per day, compared to around 400 for Telodossagia, the brown stomach worm. So, yeah, we don't need very many of them to, one, cause a disease, or two, to perpetuate it. And this is where we do, this is where we do see those differences. So yes, Haemonchus is different in many ways. Its feeding capabilities and its ability and its high biotic potential. So yeah, it is different, but actually the way we manage it is quite often very similar. So yes, I'll put a fact there, but with a caveat that it's not always there. If we think about the pathogenicity of what the disease that it causes, yeah, that blood feeding ability can cause anemia and bottle jaw, slow growth and ill thrift, and it will lead to death. But what is always quite good, and again, I think we'll hear more about it later, is it doesn't tend to lead to scour. So the images on the right hand of the screen with the eye and the bottle jaw underneath the jawline are very, very indicative of Haemonchus, but anemia and bottle jaw can be caused by other things, by fluke as well. So it can cause disease, both acute, so very, very fast disease, as well as sort of a more insidious underlying issue in chronic one. It is generally seen in lambs during that late season, or at least historically it has been, and we'll talk a bit more about that in a while. But actually, it is an issue in untreated lambs at different times of year. And what is different with this one is that we're starting to see changes in patterns. So this bar chart down at the bottom just shows it's basically data that was collected from the VI centres. And basically, it just shows that when they've looked at disease associated with Haemonchus, there is still that sort of late summer, but actually they see the disease all year through. So albeit we do see that massive peak, as with other parasites, it is starting to flatten out. So yeah, Haemonchus is pathogenic, and there's no doubting about that. But we have other pathogenic species, and we need to remember this also when we're thinking about control, that, yep, it is an issue, but we shouldn't think about it in exclusion to the others. So yeah, that bar chart was the other side of the one I showed you before. Is yep, Haemonchus, Telodossagia are pathogenic, but so are trachs and Nematodyrus under the right conditions. So yeah, it is more pathogenic than some, but not more pathogenic than others. And again, it's just thinking about the control of these things in the round. Yeah, the one that I often hear is, yep, we don't need to worry about it. I'm situated up near Edinburgh, so quite high north. And, there's that whole thought of, well, actually, do we ever really have an issue with it out with that sort of bottom part of it? And as you can see from these maps at the bottom, in 2012, the data I was just showing you can be looked at in the granularity of where were those accounts. In 2012, you can see that actually they were predominantly in that south and southwest part of it, but there were still pockets of Haemonchus in other parts. If we go forward, another 12 years, you can see that that's a very, very different graph. And there's very, very few places there where there haven't been Haemonchus identified. And again, when we looked to see where Haemonchus was, we did a survey in 2008, around 2008, 2010. And when we looked at it, we found it on about half of the farms that we looked at. We've done it more recently, and actually, we found it was a very different set of data, and we found it on about 20. And really, that's not because it's the spread's gone down or the amount of it's gone down. That just shows you there's variability within a year, variability within the samples that we take, and that is really important. And I think Jonathan and Eris and Rob are going to talk more about that sort of individuality, thinking about it in the whole. So yeah, we find it when we go looking for it, and yeah, we can find it pretty much wherever we look for. So yeah, it's not just a problem in the south of England. Yeah, if we're thinking about immunity, then actually it's often thought that sheep don't develop immunity to Haemonchus, but actually individuals can acquire immunity. As with all the other sort of roundworms, acquisition and expression of immunity is challenge and age dependent. So they need to see the challenge in order to actually develop immunity to it. A study that was done, decades ago, actually shows this very nicely, that we can see natural immunity develop. The graph basically shows the different color line, shows how many. These were artificial infections. So it basically shows how many larvae were given per week. So the larvae are the infective part. So this is to say that the green line at the bottom was the lowest amount. The blue line at the top is the highest amount. And the bar up here just basically shows you how many worms there were when they looked at this over time. And basically, yep, what you can see is that if you get the challenge right, they will drop off and they will start to come off. So the two highest ones do develop immunity, so that there's very few worms left there. If you see at the sort of 1200 and the 600, they basically don't change. And that's because they're not seeing enough challenge there to develop that immunity to kick them out. So again, it's all about exposure. It's all about how often they see these worms. So yeah, so they can develop it, and actually, there are ways that it can be managed. So vaccines are available in different parts. Those in Australia will know there's a vaccine available over there. It is basically the only gutworm that's commercially available. The other nematode vaccine is Bovolus, which is a Dictyocaulus vaccine. The vaccine works in a different way from many others. It's a hidden antigen, so it's basically the animals need to keep getting primed for it because they don't develop immunity in that way, so it's not recognized during natural infection. So unvaccinated animals need to be primed, so they need to be given doses, 3 of those doses administered during the main risk period, and then 6 weekly sort of boosts are required during the season. The vaccine is available in the UK, but it's only available from vets under special license. And really, it was just to show you that it does work exceedingly well in high regions. These were in New South Wales, in Australia. And basically, it shows that where Haemonchus predominates, we can see, 90% reduction in counts in those animals. But again, these are predominant when it only works against Haemonchus, so it doesn't have any residual effect against other nematodes, and that can be an issue for us in the UK. If we're thinking of the question about Haemonchus and surviving only in animals, we know that if we think of the life cycle, we have eggs passed out from infected animals. Those eggs develop from an egg to an L1, L2, and L3. So that development occurs outside, and actually it can occur exceedingly quickly. And that development is important because actually those third stage larvae, those L3, are what are taken up in herbage, and they're what reinfect those animals. So they can develop to an L3 very quickly on pasture, given warmth and moisture. And the moisture is important because actually, if there is no rainfall, they get trapped within the feces, and that is important to it. In temperate regions, the main way that they survive over winter is still within the host, but actually some of the work that we've been doing shows that we can have survival out with the host on pasture, and that is important. Really just to highlight that, again, work that was done in the sort of 80s shows you that all of these different parasites have different windows at which that development can occur. Haemonchus is a smaller one than others, but actually that probably is changed. Certainly the optimal is changing. And as I say, we certainly did some work up here in Scotland. We had a huge issue with Haemonchus on our institute farm. And it wasn't great for those animals at that time, but it did give us an opportunity to investigate this question. We had done some work previously where we knew that the Haemonchus could survive over the winter, but when we looked at it further on, it appeared to die off as the season went on. But what we never really were able to get at is how long those eggs and larvae would last on pasture. So what we did is we put out animals to monitor those infections. And what it really found was that, yes, the animals that we put out that had no worms in them picked up Haemonchus. So, half of the eggs that were in those Haemonchus, that were in those animals were Haemonchus. When we looked at the spring, it was slightly less, but it was about 40% and back to about the same. But actually, there's not very much drop. So we found Haemonchus eggs, and actually when we did some post-mortems, we actually found the worms there too. So we know that they were adults because we found them, and we know that they were putting out Haemonchus eggs. So yeah, it is an important survival strategy. And why is this change occurring? The parasites themselves are having to adapt to climate change the same as us. They only have one role in life, which is to pass on their genes to their offspring. So as the climate changes, the pasture and the grazing season lengthens, they have to change to adapt to that. The longer grazing season means that they are more exposed to anthelmintics, and we'll talk a bit more about that, because that then does have a bearing on how they survive, and also whether or not they develop resistance. And the final one is a more of a sort of, it needs to be more investigated, is that the sort of advent of anthelmintics that kill the juvenile stages may have forced Haemonchus to actually adapt to this and actually develop faster in the host than they have done. Again, as I say, we need to investigate this more, but it is put forward as a theory. So yeah, Haemonchus can survive on our paddocks even as high up as us. And what, the thing from that is that actually if it does overwinter, is that maybe we'll start to see infections earlier than we have done previously. So if we're thinking of the sort of final question I'd posed, multi-resistance, Haemonchus doesn't exist in the UK. I'm going to start with the single class resistance because I think that's a good starting place before we delve and dive into the multi-class one. So if we're thinking about white drench resistance, BZ resistance, yeah, we often think that we have white drench resistance on all farms, and yes, we may well do. And if we look at the panels that we have here, the graphs, basically the ones on the left are all about the brown stomach worm, and the ones on the right are about Haemonchus. And the take home from this is really, if we're looking, there's multiple ways that worms can develop resistance, and we don't need to go into that. So each of these is a different mechanism, and that's all you really need to know about it. But what it shows is, if we're thinking about the brown stomach worm, when we look at the red bars, which are the ones that are carrying the genes for resistance, we have huge numbers of those. There's lots and lots of red, and there's lots and lots of different ways in which they're doing it. If we move across to the right-hand side, what we find is, yes, we do have white drench resistance, and where we have it, these purple bars, actually, we can find that, there's almost no genes of susceptibility in these populations, so they are fully resistant. And I'll talk more about that in a second. But as you can see, if we compare the two sets of charts, there's much more red, or that sort of purple color on the left-hand side for our most predominant species compared to what there is on the Haemonchus. And that is good to know, because actually it means that there are opportunities for us to use multiple different products for controlling this parasite when we know and if we've identified it's there. So if we're getting on to the question which I'd posed, we know that multi-drug resistance is common globally, especially in Australia and South Africa and in South America. I kind of alluded to our Institute farm in 2023. The reason that we ended up with such a big issue with it was that when we went to treat it, we found it, we treated it, the ivermectin that we used at the time was 0%, gave us a 0 reduction. It didn't change the egg count at all. We then went in and we gave it a white drench, and as with what I've just spoken to before, it actually worked better. It still only reduced the egg count by 80%, or just about that, but actually it was an option, and it was something that we could use. So we do have multi-resistance, and we did have multi-resistance on our farm, and we will still have it. There's some work that was done down in Bristol, and it shows a slightly different set of presentation and results. This is basically the number of farms that they looked at that had resistance. And what this showed you is that on all of the farms they looked at down in there in 2013 and 2016 had white drench resistance. And if we look at the yellow drench and clear drench, either as ivermectin or moxidectin, we see that there was resistance to all of the anthelmintic classes. So this is the higher it up. In my one, for the Institute one, the lower down it is the worse it is. For this one, the higher up it is. So what we found is that there was lots of resistance to lots of different drugs. And there was lots of multiples there. What we need to take on board from that is that actually there was multiple species involved in this. So it's not just Haemonchus. Haemonchus was part of this, but it wasn't the only one. But I wanted to, just to put it out there, is that, yeah, we can find multi-class resistance in the UK. So yeah, we need to be aware of how we diagnose it. And again, we'll talk a bit more about that. So yeah, it is a myth. So how do we manage it? Yep. Absolutely. Avoid importation, understand the scale of the problem and what treatment will work and what to administer if it's required. And as I say, making sure those treatments have worked. I'm going to very briefly talk about that sort of quarantine recommendation. Scops have loads and loads of information, and Neris will talk more about that. But the current advice is, administering a Zolvex and Startec with or without moxidectin, depending on whether the sheep scab is suspected. So there is lots and lots of charts there. The animals should be kept off pasture for 24 to 48 hours, and that basically just allows the gut to empty so that anything that's in there prior to treatment is turned out onto ground that you can basically clean up and keep away from your paddocks. And then after that, you want to turn them out onto dirty pasture, or pasture that's had animals on it before. And that really is just there to stop anything that's there from having a competitive advantage for too long. But always, this is one point where we'd think, say, you want to check that your treatment has worked, because if it hasn't worked, you want to know that, and you can then understand where the risk is for your farm, because you'll know where those animals have been. So again, there is lots and lots of advice out there. Yeah, there is tons of advice out there. Scops has it. There's a new EU project, Spark. The Morden Institute has lots and lots of resources there too. So yeah, there's a lot. If this is sort of wet, this was really just a short, sharp stop to wet your whistle. But yeah, so in summary, yeah, we have a lot of myths there. It is something that we need to sort of bear in mind, that actually lots of what we hear isn't necessarily true. So yeah, bear that in mind. Take home message. Yeah, roundworm epidemiology is becoming increasingly variable. We do need to monitor it and target it. Use of diagnostics will help you choose the right product and ensure that your treatment has worked. Quarantine treatments are essential, and there are lots and lots of tools out there to do it. And yeah, just to say thank you, because lots of the information that's been there was gathered from lots and lots of different places. So thank you very much for that.
Thanks, Dave. That's really interesting, and I've got a number of questions, but I'm only allowed one, chairman's prerogative. Our next speaker is Rob Kelly, so I'll ask Rob if he could just share his screen. And while he's doing that, though, Dave, I just wanted to go back to a point you made in your presentation about that expanding kind of impact across the UK. We're seeing it in more parts of the UK, and without wanting to get a lecture on global warming, have you got any kind of reasons for that? Would it be global warming? Is it the movement of animals? What do you think is behind that spread?
Yeah, I think the changing climate is most definitely a contributing factor to that. I think the conditions are getting to a point where the parasite is able to survive not just over winter, but over other times of the year too. So I think that is a major driver to it. And it's not just Haemonchus, and that's what I was trying to get at, is actually it's really important for lots and lots of our parasites. We're starting to see things move into places that we wouldn't necessarily expect them to be.
And perhaps that's partly why these webinars have been so popular. The people have got more questions now, haven't they? It's always been a bit complicated to try to take the best practice advice and interpret it on farms. So anyway, pleased that hopefully we're answering some of those questions this afternoon. Thanks, Dave. We'll see you on the panel session a bit later on. So I'm going to hand over to Rob Kelly, and Rob's going to give us a presentation this afternoon about the Farmatcher tool. So it's a tool towards helping us understand the impact and gravity of Haemonchus. Rob, I'll hand over to you. Thanks.
Thanks very much. Okay, so thank you, everyone. So I'm a lecturer at the University of Edinburgh, Royal Dick School of Veterinary Studies, and I'd just like to kind of highlight, as Chris said, that we're going to talk about the Farmatcher tool that some of you will have heard about towards targeted selected treatment, but we're also going to build on some of the kind of real world examples that Dave has alluded to around the epidemiology of cases in the UK and the tools that we've got available, which will link to Neris's and John's specific examples. So as part of the kind of Farmatcher training that we've now got available in the UK, we've developed a course at the University of Edinburgh, which has been contributed by people from Morden, such as Dave, Scops, etc. And this gives us a training about how to approach Haemonchus cases in the UK. And I'll allude to this a little bit in more detail later in this presentation. Just to highlight as well, this has gone live today, and farmers, owners, SQPs, as well as vets now have access. So if you're interested in more information about how to control haemonchosis, please do take a photo of this slide, a screenshot, etc., and it will provide you with access to the course. So just to highlight these real world examples of how Haemonchus has developed in the UK, and some similar cases that we're going to build on, and some examples of how we work up diagnostic cases for haemonchosis, whether as a farmer or in collaboration with our SQP or vet. I'm going to give you some examples that we gained some experience with through our Haemonchus diversity case project here at the University of Edinburgh in collaboration with Morden. And this project really was to gather cases of haemonchosis last year in 2025 and use some of that, some of the samples that we collected to understand how that parasite is changing. I'm using them here as an example of different types of presentation of haemonchosis and how it can present, and why it's really important to take a farm level approach to haemonchosis, because as Dave alluded to, the worm doesn't always present in the same way on every farm. It's not always a problem every year, depending on the epidemiology on that farm. And also the tools that we have available are dependent on other issues that may be going on that farm, particularly parasite related. So these cases were, we asked individuals to submit samples across the UK, and this was very much a convenient sample of people that had clinical haemonchosis cases. So this is where we had animals that were anemic and we suspected had haemonchosis. And I'd just like to thank the veterinary practitioners that were involved in submitting cases for us to get access to the worms across the UK. So, as Dave has mentioned, a lot of the cases historically were in the southwest and the southeast of England, but we are increasingly seeing haemonchosis in areas of the UK that are not as warm and humid as you would normally think of where you might see haemonchus, and that's because of its adaptation. And this is an example in the Midlands where a farmer had encountered the first acute case of haemonchosis. So this was where animals presented with lots of blood loss, and it was not something that they'd encountered before, and particularly this was because it was in the later end of the season, and in fact these were in adult animals rather than juvenile animals. And again, this is from a clinical perspective, we also see haemonchosis in adult animals, not just juvenile lambs. It's another extreme example where you've also seen a case up in the Western Isles of Scotland as well. And this is again the first case in an upland extensive flock. So it highlights that this isn't just a lowland problem. Haemonchus is probably present on a lot of farms. However, the risk factors that may encounter for it to become predominant, the predominant nematode within that, or worm within that population, may be different depending on the location. And obviously the Western Isles are a lot more exposed to the environment, but they do get quite warm, etc., at certain times of year, and grazing practices might have caused this to occur. In this case, it was a chronic case of haemonchosis, and the reason to highlight that is because these worm infections can cause prolonged blood loss, and it can look a little bit like chronic fasciolosis. Now, the case was in early spring, and these animals hadn't been treated for liver fluke, and therefore it was possible that they were infected with fluke at that time, or at least had the damages of fluke. And this is why it's important to utilise the diagnostics to understand whether there is a problem or not with Haemonchus specifically. And as I've mentioned there, Haemonchus, if it predominates as a mono-infection or it predominates above the other nematodes or worms within the animal's gut, it can cause specific disease where you don't see diarrhea like Dave mentioned. And that's because the predominant clinical signs are based on the blood-sucking capability of the worm. So if we look at acute disease, where we have a large ingestion of larvae all at once through a short period of time, and that might be because of grazing restrictions, it might be because you've had new animals come on farm that have brought in Haemonchus and built up that predominant infection within the pasture, or maybe the climatic conditions allowed this worm to develop quite quickly and therefore predominate within the animal's gut. And this is where we see pale animals or anemic animals, because they're having that blood loss from the worm sucking the blood from their abomasum or their true stomach, you do get high heart rates and you do get increased respiratory rate because they've got a low blood volume. We do see this in adults, potentially if they've not encountered the infection before, as a kind of guidance. We tend to see that a lot of these species of gutworm tend to take 1 to 2 grazing seasons to develop immunity. And if adults haven't encountered it before and they are exposed to a high proportion of worms, they may not have a chance to develop immunity before they develop disease. In lambs, we can see it in late summer, but again, it's really dependent on the climatic conditions and their exposure, the previous exposure. And again, we can see that sudden loss of production. And you can see there's an animal here that we saw at the Dick Vet farm practice where the animal's anemic, and you can see it's on its mucous membranes. And equally, this is another sheep with bottle jaw, which is where they have a low blood volume, and because of that low blood volume, they develop fluid accumulation under their jaw. And these cases can be really ill, and we can go on to the diagnostics and think about if we want to open these animals up and do a post-mortem and see if we can identify the worms. From the chronic presentation, which means a long-standing slow buildup of infection, where you might have a trickle infection, where over the grazing season you might have the buildup of Haemonchus. You tend to see clinical signs of ill thrift, where the animal is slowly losing condition. And this is an animal here that we had again at the Dick Vet farm practice that was pale and anemic, etc. But it was later in the grazing season, and the animal became weak and debilitated over a period of time. Again, you can see this in adult animals if they've not been exposed to the infection before, or you can see stunted lamb growth with that. And what I just want to highlight at this stage is both of these presentations are where we have a predominance of Haemonchus, but as Dave has highlighted, by all means, there are other types of worm in the animal's gut. And if Haemonchus predominates, this is the type of clinical picture that you can see. But Haemonchus can contribute to just normal parasitic gastroenteritis in lambs as part of that mixed worm burden. And therefore, it's important to understand whether in your clinical picture whether Haemonchus is predominating, and that's often initially through clinical signs. So what I'm just going to kind of mention now is how we might utilize diagnostics, and what I should caveat this with is this is a kind of a guideline to how we might approach diagnostics with a clinical case the first time we see it, but it will depend on how we therefore go forward with monitoring for this condition in subsequent years, because each farm will have its own kind of spread of Haemonchus, and equally the risk factors on individual farms will mean that the Haemonchus ability to cause hemonchosis will vary depending on those conditions. So firstly, thinking about the farm's history, if it's the first time you've seen Haemonchus, potentially it's particularly worth reviewing grazing history with your vet or your SQP to understand if there have been any risk factors that might have pushed Haemonchus to predominate. And some of those factors that Dave has mentioned, by new animals coming onto the farm and potentially that haven't been treated, and potentially animals that have persistently grazed pasture that have maybe been contaminated by others, and the climatic conditions as well may mean that Haemonchus might predominate. But again, understanding that is important. Past treatments as well, has there been a constant use of a particular wormer, and understanding whether those wormers work or not, and have those animals got good nutrition. Thinner animals are more susceptible to gastrointestinal worm disease anyway, so gut worm disease, so really important to try and maintain their healthy nutrition. Clinical signs I've kind of just talked about with anemia and the kind of risk factors for that, and thinking about that and working in collaboration with your vet on diagnosis. It's important to consider the main kind of differentials, particularly in areas where we might have liver fluke. Of course, the time of year might help us understand whether it's more likely to be liver fluke or hemonchosis. But as Dave highlighted from the seasonality of this parasite, we might see Haemonchus occurring later in the grazing season, which might cross over with acute fasciolosis. And equally with chronic fasciolosis, where animals haven't been treated early in springtime, it might potentially be a cross that you need to differentiate between. Mineral imbalances can contribute. Copper toxicity can be one, although mineral imbalances tend to add to the clinical picture rather than being a direct differential. And equally acute bleeding can cause anemia. However, that normally affects only single animals rather than groups of animals where you might have an injury, for example, or a twist of the gut. So in really debilitated cases, we can actually use these as a way of initially diagnosing significant infection, and that's through post-mortem. And there's some pictures here kindly donated to me that were taken at the Mordum. And here we've got the worms within the true stomach or the abomasum of the animal. And if you kind of look through that digestive content, if you sieve it once the animal has been euthanized, you can see these red and white worms on the abomasum, and none of the other worms look like this. And this is why they're called the barber pole worm. Equally, you can see some hemorrhage on the gut lining, and again, that's because of the feeding mechanism around the parasite. We also have diagnostic tools to help us diagnose the predominance of infection, and particularly we can utilize standard fecal worm egg count practices, and animals with particularly high worm egg counts have historically been indicated as Haemonchus likely cases. However, that's not always the case. It depends on the other worms that are present, and John is going to talk about why not to be misled by just solely relying on the high egg counts. And actually what we want to do is to be able to speciate the eggs that are present, so identify the species of worms that are present in that mixed worm burden. And we can do that by sending samples off to the lab for peanut agglutinin staining, which is essentially a stain that's only taken up by the Haemonchus parasite against the other worms, such as Telodosargia or Trichostrongylus, that don't absorb this fluorescent colour. And essentially, once it's put under the fluorescent microscope, the parasite eggs glow in the dark, and we can estimate the proportion of eggs present that are Haemonchus. And it's not always whether it's a higher proportion, it's whether there's enough that are present that might link to the clinical picture. With the advent of automated fecal worm egg counting machines, these AI-based platforms can measure the size of the eggs and identify the proportion that are present in a similar way, and they can be done in veterinary practices. And these are quicker tools that can be done quite quickly. You don't have to be sent off to an external laboratory, and some of them are validated for diagnosing Haemonchus as well, so they can be used in that way. There's lots of genetic testing which may come online in future and essentially tells a little bit more about the other worms that are present, but they're not really available at this time. But in future, we might know a little bit more about the species that are present. And ideally, we can use those sequentially to understand the presence of different species as we go forward. And one point that's really key to mention is the presence of Haemonchus in these additional tests post-fecal worm egg count doesn't always necessarily mean that it indicates disease. I think, as Dave has highlighted, we do have Haemonchus on most farms in the UK, and it's about the clinical picture combined with the clinical signs that we see. And just briefly, we can see the different types of case, and this is why we need to take an individual approach onto farms. So, for example, down in the southeast of England, you might have flocks that have got a historic problem with Haemonchus, and therefore integrated monitoring with repeated diagnostic monitoring to check whether we've got Haemonchus present, and targeted treatments are quite important in those flocks. And this is where long-term control against Haemonchus and monitoring is really important. We might use diagnostics in a different way, particularly if we've got an initial outbreak, particularly further up in the UK. We had a case in North Yorkshire, which was the first case they had of Haemonchus, and they needed to understand a little bit more about the epidemiology of the parasite on farm, and therefore additional monitoring, as well as monitoring for the other gut worms that may predominate in different years, is really important as well. So it's not to forget about those other gut worms. And finally, we had a case up nearer to the vet school, which we dealt with, which it's important to highlight that Haemonchus doesn't just infect sheep, it can also infect other species, such as wild species like deer, for example, as Dave mentioned, cattle, but it can also be a significant infection of camelids. And where they are grazed together, initial research is showing that alpacas and other camelids are particularly susceptible to Haemonchus, both clinically, but also potentially acts as a reservoir of infection. We don't know enough about this, but again, it's thinking about the control measures for the other animals that are within that epidemiological group. So when we're thinking about planning control, and this is, I guess, why I was asked to just introduce these concepts, the similar kind of practices for other gastrointestinal nematodes or gut worms are available. The bits that I've highlighted in red on here are the fecal egg count. We have to think about speciation and thinking about, is it Haemonchus is predominating, or at least a significant amount of infection present that could be attributing to the clinical signs that we can see. And equally, we've got to think about these fecal worm egg counts in adults, not just in juvenile animals, as they may be at risk of disease as well. And if we do have a Haemonchus issue, then we might want to repeat these more frequently, just because of that biotic potential that Dave mentioned, their repeated challenge. For targeted treatments, we might also want to think about how we identify animals for targeted selected treatments, so we maintain anthelmintic efficacy. And this is where the Haemonchus scoring comes in, as opposed to daily live weight gains that we might use for other gastrointestinal nematodes when we're looking at parasitic gastroenteritis or diarrhea with the other worms. We might want to focus on the Haemonchus scoring. But all the other practices that we might need to think about, such as fecal egg count reduction tests, checking that your worms are working through the drench check or the reduction tests, quarantine treatments, as Dave mentioned in a little bit more detail. And all of these things are thinking about targeted anthelmintic use. And one thing I just want to highlight here, that you can use most of the wormers against Haemonchus as long as resistance isn't present, so they're all effective. But there are a couple of others that you can use if you just have predominant Haemonchus and hemonchosis problems, such as nitroxanil and closantel, which are also used for liver fluke. And I guess I just want to highlight that we shouldn't just over rely on those latter two. We might want to use the kind of full gambit of the wormers, and you need to think about that on an individual farm level. So just to end on, talked about targeted treatments, and particularly the Haemonchus tool. And essentially, the Haemonchus tool is a way of assessing anemia in mass groups of animals. And it's a way of doing that using a card tool to look at the eye membranes of a sheep to see if they look anemic or pale, and identifying ones that need treating and leaving those that don't need treating. And that allows us to avoid the generation of anthelmintic resistance. This was developed in South Africa, where Haemonchus predominates as a gastrointestinal nematode in the kind of early 90s, and it's been validated in that country. And we've done some work trying to validate it in the UK, and it seems to have similar cutoffs in the UK. There's some guidance on here for that, but to get access to these cards, it's important to have training, whether you're a farmer, an SQP or a vet, and working in collaboration together to integrate these into your health and control programs, because each individual farm won't necessarily have the same presentation of hemonchosis, and it won't happen in the same way each year. And this is why using these cards on their own is really can be quite dangerous if you're misdiagnosing infections. So this is just an example of what the Haemonchus scoring kind of looks like in practice. I'll just play it from here. And you can see this is me in our sheep flock, and that's an animal with absolutely normal mucous membranes, nice and pink. And you can see the card's quite easy to use, strapped to your hand. And just, there we go, you can see the animal's mucous membranes quite nicely. So it's important to note that these cards, and I really have to emphasize this, they are just a piece of paper, laminated, etc., but it's the way that you use them is really important. And actually the coloring on those cards, they're printed to a way that they exactly mirror an animal's mucous membranes. If you print these off the internet, you may not get the right color, and you might be treating the wrong animals. So we can't emphasize enough that these cards, it's really important that you get them via an appropriate source. And the way that we can access them in the UK is that we've collaborated with SCOPS, Sheep Veterinary Society, Goat Veterinary Society, as well as the Morden Research Institute as well. And we've developed a course that is easily accessible for farmers, owners of other animals, SQPs, as well as vets as well. It's live now, and if you complete the course and complete the MCQs, you'll be able to get access to 2 of these cards and via your veterinary practice. It's only 1 to 2 hours of CPD, and it's around about, and it's 14 AMTRA credits for those of you that are SQPs. And if you take a photo or a screenshot of this slide, you'll be able to get access to the course and via this link as well. So I'd just like to thank everyone for listening. And if you do have any interesting cases that you would like additional support for, please do feel free to contact me, and we can contact individuals at the Morden, as well as other colleagues that have been involved in the course if you'd like more guidance. So thank you very much, and I'll speak to you all in the panel discussion, and please do send any interesting questions there.
Thanks, Rob. That's really interesting. And I note that you, in your presentation there, you said that this is being widened out now. Availability to the cards for matcher cards has been widened out to farmers. So just a question, as I was a farmer once upon a time, how would I use the cards? Would I go on, would you be thinking that I could be using these cards as a sort of a tool myself, or is it more about me being aware of them and the vet suggesting he brings them along and he uses them? How would you see them being used?
Absolutely, good question, Chris. So really, it's a collaboration between the SQP, the vet, and the farmer to try and implement a kind of sustainable approach to monitoring Haemonchus. And if you do have an initial clinical case, then you might use these cards initially to identify animals that you need to treat immediately. And then you might use other diagnostics to monitor each year to decide if Haemonchus is likely going to be the issue. And that's why it's really important not just to follow a set of rules. It's about kind of understanding the situation on your individual farm and then monitoring. But what I would say is having access to the cards beforehand, if you think it's maybe something that you might be at risk to, it's worth completing the course, understanding the risk factors, and then having the cards online. And we've had this course available to vets in advance. So most veterinary practices that have had a case of Haemonchus, we'd recommend somebody in the practice is at least tooled up to understand how to use them.
Thanks, Rob. I'll bring Jonathan and Neris in now, if I may. Thanks, Rob. We'll see you in the panel session in a minute. Just what you guys are just going to do a little chat and then introduce who's going to do your slides. But just I think everyone's picked up in the chat. If you're AMTRA registered for your SQP status, you can get your full points by accessing the AMTRA Academy. There's a series of questions which Scots have developed relating to this webinar, and you'll get access to your full points through the AMTRA Academy. So just to make a plug for that, I'll hand over for so this bit of the webinar was really more about, we've heard some of the technical aspects of the worm and the disease and how to treat it. But what do we do on the front line? How do we take the case studies that we see, that you guys see on a daily basis, and interpret that into advice for your farmers? So I'm going to hand over to Neris, who's a sheep consultant, and Jonathan, who's a practicing vet in the Southwest.
Thanks, Chris. I think that's the really interesting bit, isn't it, Jonathan, when you put all the theory, everything that we've heard from Dave and Rob into practice. So as you said, Jonathan's a practicing vet, so Jonathan's going to cover the sort of veterinary angle of things as well. And I think it's just worth highlighting the importance of a diagnosis, which only a vet can do. So any SQPs online, you'll all be aware that that's not something that the SQPs are able to do. But we're just going to talk through some examples. Jonathan's got a really good slide showing the difference in the sort of mix of strongyles within a sample. And then I've just got 2 case studies. That they're not sort of the disaster case studies that you could come across, but they're probably the sort of examples of the case studies that a lot of SQPs would come across. So we'll just finish with those. So Jonathan, do you want to start, and then we can just do a bit of a double act?
Let's go for a share. There we go. Hopefully this will work. Is that there?
Yeah, just put it on.
So I guess to start with, I really wanted to get over the fact that when you first get Haemonchus, as Dave and Rob have said, is that we've really got to diagnose it and get a definitive diagnosis. So there's a lot of presumption out there that, oh, I've got Haemonchus. So that might be from either very high egg counts and just assuming because of their high fecundancy that Dave said that these Haemonchus worms are laying so many eggs that a high egg count equals Haemonchus. It doesn't necessarily. And the Fermatcha tool, although that is incredibly useful as a starting point, it might not be, depending on where you are. So all the Fermatcha does is indicates anemia, and as Rob just said, there's lots of different causes. So if you're in the southwest, historically liver fluke was a big problem, or the west coast of Scotland still is. There could be other things going on there. So really, first up, you have to diagnose it. And that really is down to post-mortem. So seeing these barber pole worms there in the abomasum, or at least doing a speciation, which Rob described. So working out what percentage of those strongile eggs are actually Haemonchus. Until you've got that point, you're sort of blowing in the wind and guessing, really. And then my clinical experiences has changed a lot in the last few years. So I qualified in 2012, and I've always worked in the southwest, Devon, and a bit in Somerset. And back then, Haemonchus was very unusual, really. We saw an awful lot of liver fluke and acute liver fluke. But I'd say since 2018, we suddenly saw a lot of it, then it went away a bit. But the weather we're seeing, it just is, it's giving the Haemonchus a selective advantage, I suppose, over other worms. So we're seeing it more commonly in my area. And I would historically have assumed that a very high egg count meant Haemonchus. So we used to only be able to do speciation via this peanut staining at a lab, which was quite expensive and fairly timely. So it often takes up to a week to get the results back, if not longer sometimes, which when you're faced on the ground with what product should I use and is it Haemonchus, having that delay in knowing what it is really wasn't very helpful. But there's a commercial a diagnostic tool now. You use AI, which allows us to speciate basically at the time of doing a normal egg count. And these results here show farms that we've done speciation on, and the corresponding sort of total strongyl count. And you can see that generally the higher the egg count of strongyls, the higher the suspected ratio percentage of Haemonchus is. But it really is quite variable. It doesn't go in a linear pattern, and it's certainly not every time you have a high count you have a very high Haemonchus, which I maybe historically earlier on in my career would have just assumed, oh, it's more likely Haemonchus than not. So it's crucial we do this speciation there. So I don't know whether you agree.
Yeah, and I think those figures are so interesting, aren't they? Especially that ram post-mortem 9,100. I think most would have jumped to that being Haemonchus. And it's and somebody's asked this in the question, so hopefully we'll be able to answer that question now. But there's a case study coming up. And what's the impact in your experience of knowing whether it's Haemonchus or not? Because some people might argue, well, they've got a high count, they need treating. Does it matter if it's Haemonchus? For me, it determines product choice. I don't know how to make different decisions.
Knowing how fecundant it is, and if it's your reading, this until a few years ago, when we started seeing Haemonchus, we really started reading around the world where it was a problem, Australia, South Africa, and all of this. And then we're making a decision: should we import the vaccine on a special license? Should we be using flucicide clozentel as a targeted treatment? And unless you know what your percentage speciation is, that's incredibly difficult to do, because let's look at Farm C, for example, 66%. Well, a third of that 5,200 is normal strongyls. So if you were to use a fluticide on that as a targeted treatment, you're leaving behind a significant burden, which still needs treatment.
Yeah.
So on that instance, you would be, wrong, really. Well, the farm would still have loss of performance in their animals, whereas farm D, quickly doing the maths, I think you'd be absolutely fine to use a Closentel or another product there, and preserve those other wormers for the other worms. And I think if you don't speciate and don't know and bury your head in the sand, Haemonchus could very quickly get out of control. But at the same time, what we really don't want people doing is over-egging the Haemonchus basket and over-treating, because we'll just end up in the same resistant situation as we see with everything else at the minute.
It's such a delicate balance, isn't it? You leave it too much and you don't over-treat. And I think that is a concern, is that we perhaps go back to the treatments, and we've done so much progress in the UK, definitely, with the treatment of adult ewes, that we don't want to be going backwards. We treat when necessary, isn't it, really?
Yeah.
Is there any other comments on there that you wanted to highlight of those cases? I just think that mixed infection is a real key message, isn't it?
Basically,
unlike other countries.
Mixed infection, definitely more so than I probably gave credit to. And I think that's sort of going to sheep vet conferences and things and hearing people's experiences. It really is, in the UK, a very mixed picture. And I think we'll see year on year differences. 1 year might be more of a classic gutworm summer scouring lambs, and then we might go back to, different seasons, and Haemonchus might be more of a problem. But I had, the hot spell we had at the very end of May. I've just seen here we did an egg count for someone in lambs, 5th of June, a strong goal count of 93 eggs per gram. 12 days later, the same mob, 429. So when we get this hot, dry weather followed by cooler, wet weather, it can suddenly kick off. And the other thing that I see is just not frequent enough egg counting as well. We can kind of predict it now when the weather's changing and it's going to be wet, but got to do more egg counts, speciate, not all the time because it costs too much money, but periodically know what you've got. And the other benefit of this is that if you speciate and do a pre-check, when you come to your post-check, if you've then got issues with has there been a lack of efficacy, we can then almost speciate again and really drill down and say, identify, is it a Haemonchus problem or not? So it's a game changer being able to speciate quickly.
Yeah, absolutely. Okay, should we swap slides? We can continue chatting, but we just wanted to go through, because in real life situations, the best way to learn sometimes is just to actually go through some cases, isn't it? And go, oh, you can in hindsight go, I would have done something differently, but that's how we learn a lot of the time. So let's have a look. Is that working on the screen?
Yeah.
So one case study, again, a lot of what we talked about today is assuming that farmers have got a relationship with their vet. So if anyone's listening who hasn't got a relationship with a sheep vet, please do find a good sheep vet and build that relationship. But SQPs obviously also have, and quite often the first point of contact for a lot of sheep farmers. And these two case studies are potentially ones that would go via the SQP channel rather than perhaps the vet. But I think it's really important that SQPs are aware of all the additional testing, so that at least then you can have a conversation with them and say, look, if you talk to your vet, ask for this test, and sort of know roughly what time lag you're looking at, maybe cost as well. So you can warn the farmer, this will cost you 40 quid, this will cost you, roughly that amount of money. But this first case study was an April lambing outdoor flock in the Midlands. And they did routine ewe fecal egg counts, and they never exceeded 100 eggs per gram. So they were concerned about a new worm. This was prompted by their neighbour frightening them, but that's just an aside. And they actually had a ewe result of 2,500, which they felt was quite suspicious. So they thought, oh, I wonder what this is about. But that then drove them to go and have a look at the sheep. So they were going in to treat the lambs anyway. And they thought, well, I'm there, I'll have a look at the sheep. And they found that some ewes had lost body condition compared to when they were last treated, pulled the eyelids down with some of them, and also visibly noticed some bottle jaw. So the egg count itself was suspicious, but then there was another layer of additional concern. So the sample was then sent off for PNA staining. Now that was before the commercial AI option was available. Now there was a discussion at the time, well, is there any point, because I want to go and treat them now? And Jonathan has alluded, I still think it's worth doing. Even if you treat them and send the sample off, you're still going to have information in hindsight, aren't you? Even if it comes back and says, oh, it's not Haemonchus, you haven't waited. And I was actually very impressed, because with this, that PNA stain came back in 2 days. So we were very impressed with that. So the outcome of doing that was, like I've mentioned, we had clinical signs plus fecal egg count results that justified the action in the group. But they went and spot treated all the ewes that they felt were struggling, because the count was 2,500. They didn't know the presence of Haemonchus at all then. And importantly, they marked the ewes that they treated. Then when the PNA staining came back at 66%, so this had gone through the vets through to APHA. And just to be aware, I believe it's still subsidised this year at 50% cost. So that option is still available if people would like to utilise it. And then importantly, what was done, those ewes that were marked were gathered up 7 days later to check that it had worked, because they'd never had Haemonchus on the farm before. He'd gone in with a levamisole because that's what he had on the farm, and he wanted to make sure that it had worked. So went in 7 days later, and there was a 93% reduction, and he reported that the ewes looked better and the bottle jaw was clearing up. So the learning points for this was using the FEC and species identification alongside the clinical signs, didn't just look at one of those and make a decision. Previous low fecal egg counts were sort of ruling out that it had been a grumbling problem for a really long time, but also didn't think, well, my FECs are always low, therefore I'm not going to test my ewes again. Did the selective treatment, which, you know, treated the ewes that were struggling, but avoided any blanket dosing, especially because at the time it wasn't known whether it was Haemonchus or not. And because animals were marked, they were able to check those specific animals, and that the treatment had worked. And I think that would be, you know, a very, it's not the Haemonchus case that you'd perhaps be used to hearing. A lot of the cases we hear might be sort of mortality and bigger problems, but I think there's this grumbling impact, and because 2025 was quite a discussion topic for Haemonchus, there's a lot of people asking questions about 2026 as well. Then this farmer just kept monitoring every 3 to 4 weeks, every time got the ewes in, have a look at the eyes, and routinely did fecal egg counts. So that's a very quick case study, but there's a couple of things all interacting there, and didn't just go off the back of a high count, but had all that information with them. And now the second case study is a Southwest farm in a completely different time of year, different part of the country. These ewes were split just after weaning into 3 groups, and after 3 weeks, the farmer was concerned that the thin group weren't improving as much as he would like them to, despite the fact that they've been given the best grazing. So took a fecal egg count, and the egg count came back as 1,900 eggs per gram on the strong giles. Now, it was 2025, and Haemonchus discussion was on everybody's lips. So the farmer was worried about Haemonchus, and we'd actually spoken about it before, and he'd said, well, I'm worried about Haemonchus coming. And I said, well, when we find it or something happens, we'll deal with it. And because the egg count was high and it was his thin ewes, he was trying to get them back up for tupping, he considered using a closantel-based treatment to get the ewes. But luckily, his vet practice had the species identification kit, and they were able to run it that same day, and it came back as only 3% Haemonchus. So what was really interesting there was, yes, it was a high count, and yes, the ewes were thin. They weren't thin because they were struggling with Haemonchus. They likely had a high egg count because they were the thin group. And that actual proportion, to me, meant more than that total egg count. So what we learned from there was, well, first of all, the farmer was relieved in a way that Haemonchus was there and it hadn't come in the dramatic fashion that perhaps a lot of people have sadly experienced. So there was an element of, okay, it's here and we can manage this. But I think the most important thing here is that if he had gone in with a chrysanthemum-based product, what would have happened is it wouldn't have fixed that 1900 egg count, because so much of it was not Haemonchus. We would have ended up, when we did an efficacy test a couple of weeks later, there would have been two outcomes. There would have possibly been a discussion on the chrysanthemum not working, which wasn't correct because it wasn't actually treating the right product in the first place. But we're also still going to have an egg count of over 1800. So we've lost another 2 weeks of time, those ewes eating the grass in front of them, but not gaining any condition. So we would have at least delayed progress by 2 weeks, waiting, retesting, reassessing, and then maybe going down a little bit of a rabbit warren before deciding that actually the reason it hadn't worked was because we'd used the wrong product. So really, I know we're talking about the species identification, but the SCOPS guidance sort of suggests not to overtreat. That's our guidance, but sometimes we need that additional information to enable us to do that. And as I think hopefully we've alluded to, the proportion and the context is just as important as a figure on a fecal egg count report. So sort of takeaways then, the presence of Haemonchus itself is not a disaster. I think it's something we're going to have to start to learn to live with, and that moving away from a fixed eggs per gram threshold is potentially the way to go. I do get asked quite often, I don't know if you do, Jonathan, as well, but at what count should I do a species identification test, and then at what percentage Haemonchus do I treat? And unfortunately, there is no blueprint. It's focus on the proportion, the context, the risk. And we have got lots of treatment options out there. We're not in the situation where we have got lots of products that aren't working on multiple farms, but we are in that position, and it would be good to stay there. So the SCOPS principles underpin all of those things that we talked about, whether it applies to Haemonchus treatment or worm other parasite treatments. So the questions I tend to ask would be, why did the farmer do the fecal egg count in the first place? That often will, if they say I'm worried about them, then that sort of ticks something in my head. Which animals were sampled? How are they looking in general? That's always an important one, because if they come back with an egg count of, that's quite high, but they're looking really, really well, it's a different conversation. Then have you noticed any clinical signs, which will normally come along the question of how they're looking in general? So are they consistent? Does the result feel right? And if you've got any historical fecal egg counts, that's another one. So is this going up? Is it going down? Is it staying the same? And as Jonathan's example earlier, just in a week, that it changed quite a lot in that group of lambs. So then what options are there available for species identification? So we've got the PNA staining, which has to go off the farm to a lab. It is subsidised at the moment, but there is, as people have alluded to, one commercially available product at the moment. I believe there are more coming to the market. There is a published paper out on the feasibility, the specificity of that compared to PNA staining. So that might be something we need to try and find and put in the chat for people who would like to read that. Obviously, it's not something that SCOPS advocates one over the other. They're both options that are available, but it's that interpretation that's important. And then if it's decided that obviously a treatment is required, what's the flock's recent worming history? Are they a massively fluky farm and therefore used fluicide products in the past? How well do we know these products are working? But it won't be the same as Dave alluded to. If they've got white wormer resistance, it doesn't necessarily mean it's going to be resistance to Haemonchus. But then checking that efficacy will help build that picture up on that farm, so that, the next year the conversation could be around, well, last year you used the yellow and that worked at X%. So this year, why don't we try a X and look at how well that's working? But of course, it will depend on the severity of the outbreak. And I don't know if Jonathan wants to say something, how it would be different in a situation. These two are much milder examples and potentially ones that might not get as far as the vet for a diagnosis. And it's something that the SQPs would come across. But as a vet with dying ewes, it might be something that you want to comment on, Jonathan. But just before that, I just wanted to highlight other resources that we've got on the Scops website. We've also got a Scops podcast channel, which has a Haemonchus specific podcast, if anyone's interested in that. And then we've got this webinar will appear on the YouTube channel. And then there's a Haemonchus guidance PDF as well that people might like to go and read. But Jonathan, did you want to make a comment on other things you would consider if it was a more extreme case? Because that's something that SQPs are unlikely to be dealing with.
Generally, the extreme ones, the farmer will find dead lambs and give us a ring, and you just open them up and you diagnose it there, and then you open up the abomasum and it's easy. Probably 2018-19, when we started seeing a lot of cases, we had a lot of farmers who'd never heard of Haemonchus, and they essentially got caught thinking, especially in the southwest, liver fluke used to be the thing. Wet in the southwest, they were used to seeing liver fluke. Often came at the same time of year as acute liver fluke, acute fasciolosis. September time, and we're treating with triclobendazole for acute fasciolosis, and it wasn't working, and then they come along with bag of dead lambs or ewes. I think hopefully the word is out there now that Haemonchus everyone's hopefully heard of it, so we're not getting quite to that stage. Ewes is the one where the standard advice is that ewes generally are immune against gutworms. That might not be the case with Haemonchus, especially if they've never seen it before, if it's become a real problem on your farm and they've just not got that exposure previously and good immunity. So I always say, even if you're not for maturing, is just check eye color reviews whenever you're handling them, body condition, eye color. Just get it, whenever they're there in front of you, just do it. Same with lambs, just eye colour. It's cheap, it's free, isn't it? You've got your hand on them, it's free.
Yeah, collect as much information as you're there. I was just saying, we've got questions, Chris. So should we start bringing those questions into the panel, and then
I'll bring Dave and Rob back onto the screen, if I may.
Yeah, got some great questions to get through.
There have been some really good questions. Just on that fecal egg count reduction test question, can we keep the answers pretty brief, guys, if we can, because we've got quite a lot to get through. What's the time between a treatment and then doing a fecal egg count reduction test? So
it's 1 week for levamisole, 2 weeks for everything else.
Yeah, the question was specifically about closantel, so that would be 2 weeks for closantel. So you treat, and then 2 weeks later you do a fecal egg count.
Oh, closantel, yeah.
Is Dave there? Dave is.
I'll put you on the spot there, Jonathan. Sorry.
Yes, no, it would still be. I think, Jonathan. I think you'd still go in 2 weeks after that, and then that would be the timing for it. Because it should kill off the juvenile stages. So
just I'm going to try and merge some of the questions so that we can get through all of them. Hopefully an easy one. A few questions about resistance in breeds. We often get this when we look at disease. Specific question about Scottish native breeds, but another one about South Downs. But any views, anyone, on whether there's any resistance across any of the breeds? Nothing scientifically proven. Dave, you're not sure?
I think, there will be variability, but I wouldn't be using that as a way of doing it. I agree with the shakes from those two. I think there is inherent variability. There are some of the sort of hair breeds that have been seen in the tropics that are more resistant than some of our other ones, but that would not be the way I would be for them sitting.
Again, another quick one. Fecal egg counting cade lambs have been put out to pasture from 7 weeks. What sort of frequency would you be thinking? So this is responding to the challenge of more fecal egg counting. What would the frequency be, or would you kind of be looking for other things to guide you?
It's sort of 3-ish weeks, but it depends a lot on the weather, and as Neris pointed out, the egg count, the previous egg count might drive that decision as well. So it's art and science. So you know, if you've got an egg count of 350, let's say, and you're going on holiday next week for 2 weeks, and the forecast is it's about to rain, that 350 is going to explode very quickly. Whereas if it's 350 and we had the hot weather of last week and that's due to continue for 2 weeks, it's unlikely to change. And then you factor in, how are those lambs or ewes performing? What condition are they in? How quickly are they going to go to slaughter? Everything else, you can delay it. But the hot weather we had last week, if we have any meaningful rain this week, it's just going to go boom, you know.
Yeah. So that was
I
another
think-
question.
Sorry, I was going to say, Chris, and I think that's what makes advice on parasite control so difficult, because it used to be you go in every X week and you do X. Now it's test every 3 weeks, a group, but if it's this, test more often. If it's that, you can leave it a bit longer, and it just becomes very grey. So 3 weeks would be the sort of rule of thumb, but variability. So
on those weather conditions, and we've just had this dry, hot spell, there was one question about Haemonchus going to ground in sunshine. I'm just going to wrap that up in Jonathan. This could be Dave or Jonathan or anyone. The general rule I always had was, if we've had a dry period and then it suddenly goes wet, you said meaningful rainfall, Jonathan, then expect an explosion of worms, because, as you said, Dave, they sit in the feces, and then when that moistens up, they come out. That's the same for Haemonchus, isn't it? Would that be the same, or is it any different?
Yep, it's all the same. Yeah, as Jonathan says, and I think whilst it's hot, they get trapped. So if they hatch and develop, they'll move in and in and in to the feces. They'll actually actively move away from the dryness. And then, as Jonathan says, as soon as the pack gets broken up and there's lots and lots of rain there, everything gets released. So that's why you start to see that huge issue, is because they're getting a massive hit of these things really, really quickly, you know. So, and they won't have seen it before, because everything's been trapped. Everything gets trapped into the feces because they can't really escape.
So that's one of the key points to then influence that timing of the feed leg counts and consider change. Just going on to just a quick one, possibly for Jonathan again. Sorry, they're all heading your way at the moment. Wildlife, are they a contributor to are they like a host for Haemonchus?
I think insignificant, really. I saw the question about deer. I mean, if you're talking 500 lambs in a field or 20 deer that occasionally pop in,
issue. Yeah. So I'm going to take us on to the big topic in the questions, the speciation or species identification. I might start calling it, because I struggle with speciation. My question was going to be, if I'm a farmer and I want to get that, can I get that from, is that going to be available from all vets, or is it only specific vets who've invested in the kit? Can you guys give me a bit of a guide as to how freely available it is at the minute?
Can we use trade names or not? Are we?
As long as we say other forms are available, and I think as long as we give everybody a fair shout, I don't see why not.
Well, there's lots of tools. So there's FECPAC, there's Oversight, and there's Micron, and they all use AI to do egg counts, and they are all in the process of developing speciation. So Dave will tell you can speciate by eye Haemonchus, but it's incredibly skilled and like it would take forever. But machine learning, we can do it. Now, Oversight have launched last year their speciation, so they're the ones that are available, but the others are developing. I think that's fair to say, given them all. So they're coming. My practice has Oversight, lots of others do, some have Micron. The way it works is you can do an egg count on the machine. Practice would charge whatever they charge, and then for Oversight, the practice buys an additional credit, so there's a small additional fee to run the speciation, and a vet practice will charge whatever they want on top of that fee. But it is significantly cheaper than sending it to an external laboratory, and the benefit is, how I use it is I do an egg count, it comes back as say 3,000, I'll hit speciate, and I know within minutes what that percentage is. So then we can have that conversation. Do we use a targeted treatment or not?
Yeah.
I don't think you need to be doing it every single time you did an egg count every 2 or 3 weeks. That would be too costly and unnecessary. But periodically, or especially if it's a new farm that's never really had Haemonchus before and you get one of these very high counts, the 2 cases that Neris had, you know, having that information there is really useful.
So it is a bit more costly, but when needed, it's important.
It's minimal. Yeah.
And just to be clear, then you would recommend it for Haemonchus. It's okay for Haemonchus.
Well, yeah. I mean, if the paper was, it's probably
It's
open
released
access,
at Christmas.
isn't
Yeah,
it?
it's released at Christmas. Yeah, it's available.
Yeah.
Yeah. So if we can try and find the link to put it in the chat, anybody. If I try and do that, I'm going to lose my trail of thought. Can't multitask. But it has been peer reviewed and it is out.
So my take on that is this is a really important thing to talk to your SQP and your vet about. If you've got suspicions, those sorts of tools are available, but you're going to have to talk to your vet as the first line of approach. And then if the vet's not doing it, then you would find somebody who offers it as a commercial tool somewhere else.
Can I just add there though, Chris, that if the vet
Yep.
hasn't got an oversight, every vet practice can send it off to a lab.
Yes,
Yeah.
that's what I'm saying.
Yeah.
DNA
But
is still
farmers
there.
can't send it off. So I've had a client that wanted to send something off. So I said, you go through your vet and the vet will send it off to the lab, and then the results goes back to your vet, and then it comes back to the farmer. So it's not a case of if they don't have an oversight in your practice or you can't have it done.
No.
And also remember, all that APHA data goes into surveillance and all those other things. So there are other benefits for doing that.
Yeah, and as Nara said, you know, she got a speciation back PNA in a couple of
2 days, yeah.
It's just how many have they had, and it's probably one of these tests that's done once a week, and it, you know, when does your sample arrive in the lab and things, and but you know, even 2 days, if you're dealing with an egg count in the high thousands, that's, you know, you don't even want to be waiting that long sometimes. So
there's quite a few questions about grazing management, really, which takes us into another complete webinar in terms of grazing management and so on. Neris, would you say better to manage the grazing for the grazing quality than to manage the grazing for its worm challenge as a general point, or
the difficulty is we can't see the worm challenge, can we? We can see the grazing, and there is that link that animals that are fed well will have a good immunity, and therefore will be able to, you know, keep that immunity up and not fight the parasites, but, you know, have a better tolerance to them. Not lambs so much, because they're old when they're getting it when they're younger. So yeah, I would say you know, you've got to manage the grazing, but we know that grazing right down low, most of the worms at the bottom few centimeters, so they're more likely to graze, but that's not ideal for grazing for the growth to return or parasite control. But there is a PhD happening at Morden looking at rotational grazing and strong gale infections, because that's something that I get asked a lot. You know, is rotational grazing better or worse for parasite control? Don't know the answer yet, but we will see.
Yeah, maybe that's something we can come on to on another webinar. I do want to deal with one question that was in there about moving lambs to sheep, a flock, to silage aftermath, a refugia question, because I think that's often another one that's misunderstood. So this person was asking for advice about moving flock to silage aftermath. Would you treat with Zolvix or Startect? Who wants to pick that one up?
Can you read the whole question, Chris? Can you read the whole question?
Yeah.
Sorry, just for context.
I'm going to try and summarise it. The person wanted to ask, if you're moving lambs to silage aftermath and you wanted to treat them before you move them, if a farmer with known Haemonchus is planning to move a flock to silage aftermath, what would you suggest treating with, and would you do the whole flock? Would Zolvix or Startec be the right option and treat as a quarantine dose? I'm hearing some alarm bells in that question. Who wants to take it? And we might go over time, but I think this is a really important issue here, just to cover off at the end of the webinar. Sorry, it's coming at the end.
I would be asking, sorry.
No, go on, Nurse.
I would be asking why Zolvix and StartAct. Is it because they don't think any of the other products work? So why, I'd be asking why that product to begin with. And then you might sort of instill down that actually it's because they think that works best for Haemonchus than any other product, which may or may not be the case on that farm. That would be one question I'd want to ask. But Dave, were you going to say something about the contamination bit?
Yeah, well, I was going to say, do they need it? You know, that would be the question is, do they require that to be moved on to silage aftermath? The assumption is that it's a much lower contamination rates when you get on there, and that's a bit of the question you're going at is, if they go on and they've been treated and things survive, then you run that risk of propagating your resistance, and that bit is one of it. So yeah. My point would be that the question of, are they needing it? And then deciding on what that treatment is. What I would say is, if you are going to do it because you've decided that is necessary, just make sure it has worked. You know, and it was going back to your point before, Chris, about the sort of the pasture management. The other thing is, if you know what they're carrying when they go on to any of these fields, you know what that risk is for future animals, and then do you need to do something about it? You know, if they go on to the silage aftermath and the count continues to be high, that is a risk for going forward, even as silage aftermath, because you're contaminating those paddocks.
One last question, hopefully it's a quick one. It's to do with spring outdoor lambing, really, and well, combining our drive to reduce the amount of anthelmintics we're using in the pregnant ewe around lambing time, but specifically thinking about those people who are lambing outdoors. Do you think that has built up the worm count in the ewes so that we're starting the season with a higher worm count outside? I don't think it's specifically related to Haemonchus, but is there a quick answer to that, or do we build that into a grazing session another time? Nerys, I'm looking to you.
My response would be that I don't think, because I think I saw the question, Haemonchus doesn't appear because we've not treated. It might be that we were keeping it at bay previously by treating, but we were doing it by accident. You know, that there might have been some Haemonchus there, so we were treating really for the wrong reason, but getting the right outcome. So I would say, if you can still do fecal egg counts in your ewes, it doesn't mean you just don't treat them. And, you know, you can still fecal egg count outdoor lambers. So you can sort of see that pressure, because we know the periparturient rise, which is the risk, will vary from farms, whether it's 4 weeks before lambing, just at the point of lambing, or 4 weeks after at peak lactation. So I'd still recommend that. What I'm sort of a bit adverse to people doing is going back and routinely treating their ewes at lambing, thinking it will avoid Haemonchus. It could be that the two things have happened completely on parallel. There might have been some crossover. We'll never really know. But defaulting back to what we used to do for a different reason, I wouldn't recommend that. I'd say, let's go back to basics. Let's do fecal egg counts. Let's see how it's going. When is it coming? And then we can identify what the species are and then go from there. I don't know if the vets would agree there.
I'm increasingly seeing on some, but not all farms, problems throughout the year with worms and ewes that is not always Haemonchus, so classic strong gulls. So we made a move off the back of Learmont's paper about we shouldn't be worming ewes blanket treating. I think what we really should be doing is egg counting ewes pre-tupping and pre-lambing, and knowing what you've got and then treating accordingly, instead of just saying we don't worm ewes except maybe ewe lambs or triplets or whatever generic advice it is. Some farms I haven't wormed a single ewe for 4 or 5 years, and other farms still do. And it's, I think, just egg count specifically pre-lambing or at lambing and pre-tupping.
Can I also get the word body condition score in, Chris?
And body condition score, yeah. And whilst you're at it, for matcha.
Yeah, just
And I
because we
guess
know that
just to-
using better condition will.
Yeah, I wanted to bring you in, Rob, if I may. Just one question for you, because there was a question about access, farmer access to these things via online. I think that's been well covered because there is a training course that comes with these cards, and that's what you're paying for by buying them. Do you just want to cover that question off quickly?
Yeah, I guess just to acknowledge we're not making vast amounts of profit from these cards. It's authorized by the University of Pretoria. And the reason that we have to provide training is just because of all the discussions that we've had. Essentially, the training, what we try to do to kind of give extra bang for your buck is that there are case series produced by vets in practice across the UK, as well as training from Morden, such as Dave and Scops as well, to try and integrate all of that together to highlight why these cards, if they're just used without that support, you can lead to misdiagnosis. So this is partly why. The other reason is that we want to kind of highlight that actually Haemonchus isn't the predominant gastrointestinal nematode in the UK. It's a mix of those, and again highlighting why we need to kind of take a tailored approach, and I think we've all kind of discussed that. And to kind of add to that picture about the ewe example, understanding your grazing practices on an individual holding is really important, and what happened on that pasture the previous year really does inform what's going to happen the next year. And we know that with Haemonchus, as some of the research is showing, that actually it's not just animal to animal transmission, it's also overwintering on pasture because of climate conditions, etc. As well. So lots of different elements that we kind of need to support with that training.
One last question. I don't know if anyone can answer this. What's the kind of, we talked a little bit earlier on about the weather, and how long does Haemonchus last in the pasture? Is there so if you were going to give a field a break, I guess that's where the question's coming from. Is there a period after which it would still be infective, or?
So
we don't know.
So larvae can last for a long time on pasture. The sort of general rule of thumb is that after 6 months that you've got rid of most of them, but 12 months is probably better. But you have to remember that where there's shelter belts and where there's walls and fences and these sort of things, they may last longer than that because they generally are killed off by UV light. They're generally killed off by drying up and all the rest of these things. At shelter belts, that can mean that their conditions are much nicer for them, and they're not getting the thing. So the rule of thumb is that 6 to 12 months, but be aware that your paddocks are never going to be clean. You're never going to get rid of them. They're there. You will just reduce the numbers.
Guys, I'm going to call it to a halt. I'm not sure we've answered all of the questions, but I just think the fact that those questions were firing in there on a range of issues, there's a lot of interest in this area. We'll take some of those areas of those questions about grazing away and think about those for a future webinar. In terms of talking about future webinars, we are doing one with cows, which is the cattle version of Scops. And that's on the 20th of July, and that's focusing on lungworm. So if you've received information about this webinar, have a look on the Eventbrite site or follow that. We've got another webinar on the 20th of July. I'm going to say thank you to all of you guys. It's been a really interesting afternoon. We've had a fantastic attendance right through to the end of the webinar. Dave, thanks, and thanks to Morden. Rob, thanks to you and Edinburgh. Jonathan, for giving up your time this afternoon from practice and real work and paid work. Thank you very much. And for Sheep Vet Society support as well. Thank you very much. Neris, as always, thanks to Scops and for all the information you provide. Look forward to doing another one of these with Scops in the future. Thanks very much, everyone. The webinar or the recording of this webinar will be on the Rumour website later on this week. Thanks to everyone. Have a lovely evening and goodbye.